Hello there, Gregory Carlson here for College Algebra. This next page of notes for 2.5 is extremely important, and there's a lot of stuff on here that's not going to be on the test for now, but I wanted to introduce it now so you can start to get familiar with it. This page right here are all of the parent functions. They're kind of each like a family. They're a family of graphs, and the one I've given you here is the most basic version of that graph, or the least complicated, or simply the parent function. And so it's important for you to memorize what all of these graphs look like, to understand the similarities and the differences between all of them, and because when you get to calculus, you're going to want to know all of these and how they all behave, because it helps you be able to do calculus better. So let's go through them one at a time. You're going to notice, let's just start with the line and I'll explain what all of these pieces mean. So here's the line y equals x, and you'll notice that the line y equals x, maybe one of the most basic functions, is just a line with a slope of 1. So it goes up 1 over 1, up 1 over 1. You'll notice that it's an odd function. We'll talk about that in a minute, but basically an odd function means that any point up here in the first quadrant is going to be down here in the fourth quadrant. In other words, if you have a point on here, when you go to the negative of that, it'll be the negative of that point. So we'll explain that some more later. Notice that the domain and the range are all real numbers, and so they go from negative infinity to infinity. There's graph for all of x and graph for all of y. And lastly, let's talk about this end behavior. This is really important. Notice how it says x arrow negative infinity, y arrow negative infinity. What that means is as x goes to negative infinity, in other words, as we go this way, what's the graph doing? And we can see that as we go this way, the graph is falling. And so that's why it says y goes to negative infinity. So as x goes to negative infinity, y goes to negative infinity. And vice versa. As x travels towards positive infinity, the end behavior of the graph is going up forever. So let's look at another one. Let's look at the absolute value function. Whenever you see a function with a point like this, like a corner, you should immediately recognize that it's almost probably absolute value. So notice that its domain is everything. We can plug everything into an absolute value, but the range is no longer all real numbers. The range is now slightly different. It's only going from 0 to infinity, including 0. And that should make sense because you never get a negative out of an absolute value. It's always going to give you a positive answer. It's an even function, which means that it's symmetrical across the y-axis. And so if this was a mirror, you could see that it's going in both directions. End behavior is a little bit different. We see that x goes to negative infinity. Unlike the line, as x goes to negative infinity, y goes up to positive infinity. And as x goes to positive infinity, y goes up forever. So we see that these two are both going y to positive infinity and not one and then the other. I'm not going to go through all of these in detail, but again, you should take the time to study them, memorize them. Don't memorize all of this. Instead, memorize what the function does, and then this will become obvious if you know what the function is. A quadratic is almost similar to a absolute value, except that instead of a point, it's a curve right here. And but the end behavior is the same. It goes up forever. This is the graph of like y equals x squared. Notice again that the range is only 0 included up to infinity. This one is another one you should recognize. This is the square root function. It goes out like this. It starts at 0 and then it goes up. In a way, this square root function comes from finding the inverse of this function, the x squared function, which we'll talk about later. Notice that there's a restriction on the domain with the square root. Remember how we talked about there's a restriction on the domain of square roots? There's no graph over here because if we plug in a negative number into a square root, we get an imaginary number. And since this is the real plane, we don't see that on our graph. And so you can see that the domain is only positive and the range is only positive because we can only plug in negative numbers and it only kicks out. We can only plug in positive numbers and it only kicks out positive numbers. Notice the end behavior as x goes to infinity, y will keep going up forever. Here's the cubic function. Notice that it's an odd function because if I plug in a positive x value and get a point, if I plug in that same negative x value, I get that same negative point. So that's what makes it odd. Notice that a cubic function has no restrictions on domain or range. We can plug in whatever we want. It gets big pretty quickly. Here is the cube root function. In other words, taking the third root of something. You might notice it's almost as if we took this and kind of laid it over on its side. Do you see that? So that's not on accident. Here's some functions we'll talk about later. This is an exponential function of the form y equals some number to the x. It grows like this, exponential growth. And here's a log function, y equals log of x. It's really important that you notice that we can't plug a negative number into a log, and we'll talk about why in a future chapter. But just get a sense of what an exponential function looks like and what a logarithm function looks like, because we're going to look at them in more detail. Here's y equals 1 over x, which moves like this and like this. Notice it's discontinuous, it's undefined at 0 because we can't plug in a 0 into the bottom, into the denominator. And so you'll notice that the domain is everything except 0 and the range is everything except 0. So they've cut out 0 for both the range. There's an asymptote there, a line the graph never touches, and there's an asymptote here, a line that the graph never touches. Notice that if we make it x squared instead of x, basically it makes this negative part become positive. And so they're both positive reaching up towards infinity at the line 0. And so as, by the way, notice that as x goes to infinity and as x goes to negative infinity, you'll notice that y approaches 0. So in these other graphs, y was it going up forever or down forever, but here y approaches the line 0 as x goes to infinity or negative infinity. Finally, we should know what a constant line function looks like. It's just a flat line. And notice that the end behavior, y approaches that constant number because that's what it is all the time. Finally, this is a stepwise function. We don't see them that often. Basically, think of it as kind of like a rounding function. Like if we were, in this case, if we were rounding down to the nearest integer, meaning no fractions or decimals, then we'd be 0, 0, 0, 0, 0 until we hit 1. And then if we're rounding down, we'd be 1, 1, 1, 1, 1 until we hit 2. And then if we're rounding down, it would be 2, 2, 2, 2, 2 until we hit 3. So that's essentially what this is. Those kinds of functions are useful in programming when you're trying to round to dollars or something like that, or to a certain number to keep the calculations simple. But we don't see them very often, but it's still important to know what they look like. Notice that all of these are functions because all of them pass the vertical line test. You should make flashcards. When I was in pre-calculus, we did a little dance to know all of the functions. But you should know how to recognize all of these functions from their graph. And if I show you their equation, you should also know roughly what the graph looks like and at least be able to draw it. Remember that if I ever give you an equation and you can't remember what it is or what it looks like, just plug in some points. Plug in 0, 1, 2, 3, or -1, -2, -3, and see what the graph does. And you'll be able to connect the dots and get the rough outline of the sketch of the graph. So make sure you study this page. This page is very important. We'll be talking about a lot of these functions in detail. And that's it for 2.5. If this video was helpful, please like and subscribe, and I will see you in section 2.6. Thank you very much.